Bright Duty. Every student matters.
Hello students, my name is Sanjay Jain. Today we are going to discuss an important chapter of class 10th, that is triangles, right. It is a very simple chapter if you understand the concepts well. Now this chapter you have seen in class 9th also. In class 9th you studied about congruency of triangles, right. In class 10th, this was in class 9th, right. In class 10th we will discuss about similarity of triangles, right. This will be in class 10th. Now what is the difference between congruency and similarity? Congruency in geometry means equal, right. When two shapes are exactly equal, that is exactly congruent, it means if one shape can completely overlap the other one and the other one can completely overlap the first one, then they are said to be congruent. So they are of same size, right. And in similarity we will talk about same shape, right. In congruency they are exactly equal, right. Their shape is also equal and their size is also equal. So they are of same shape and same size. And in similarity we will talk about only shapes, right. What I mean to say is, let us say you have got a photograph of Taj Mahal, right. Now you may have a passport size photograph of Taj Mahal and you may have a bigger photograph of the same Taj Mahal, right. Then these two photos are said to be similar to each other, right. They are not congruent to each other, okay, because they are of the same shape but the size is different, right. Similarly, if you have got, let us say, two circles, this circle is of 1 centimeter radius and another circle you have got of 2 centimeter radius. Now the shape is circle for both these figures, right. So the shape is same because both are circles but their size is different. And how do you determine the size of a circle? By looking at the radius. Now this radius is 1 centimeter, this is 2 centimeter. So they are not of same size but the shape is same, hence these two figures are similar but not congruent, right. Now let us look at another scenario. If we have got two circles and both have radius 2 centimeter, right. These shapes are same and the radius is also same for both of the circles. So the size is also same. So same size, same shape, hence congruent. Now if I ask you, are these similar? You will say the shape is same, hence these figures are similar also. So yes, these are similar too, right. So what can you say from it? That congruent figures are similar but similar figures may or may not be congruent. When are they congruent? If I give you two similar figures and I ask you when would they be congruent, they will be congruent only if the size is exactly the same, right. So the similar figures may or may not be congruent, but every congruent figures are similar. Give me some more examples. Let us take two equilateral triangles. In an equilateral triangle, all the angles are 60 degrees, and if one side is A, then the other two sides will also be of the same dimension, right? We have got another equilateral triangle, then the angles will also be 60 degree in that triangle also, but the dimension may be different. Let us say this time dimension is B. By dimension I mean the side length, right? Now are these similar? Yes, these are similar. Why? Because you need to understand this concept that if you can stretch a figure and convert it into the other figure, for example, if I stretch this figure here, right, I need to stretch all the sides, right, and I can obtain this figure by stretching this figure. That means these two shapes are similar, okay. And by stretching, when I say stretching, if you can use a word scale, you can use scale up or scale down. By scaling up I mean, let us say this is the side, okay, and this is another side, this is the third side. If I am scaling it up or I am stretching it, that means I am stretching all the sides equally, right? So I'll obtain this figure by scaling up this figure. Similarly, I can obtain this figure by scaling down this figure, okay. When I scale up, I'll introduce another term here, scale factor, right? This will convert into this triangle, right? By how much? What will be the ratio of sides now? It will be B by A, and B here is greater than A, right? So B by A is the scale factor, right? This is the scale factor. Scale factor tells us by how much, by what ratio are we stretching the figure, right? So we can stretch a figure to obtain another figure, or we can squeeze a figure to obtain the previous one. Now while stretching or squeezing, we should maintain that we are stretching or squeezing all the sides equally, right? So this is the scale factor when we scale up, right, and when we scale down, this will be the scale factor. What is the difference? Numerator is bigger, denominator is smaller. Now if you multiply this B by A in this side, A into B by A will give you B, that is other side, and when you multiply A by B in this, so B into A by B will give you A, which is the smaller side, right? So the scale factor for scaling up will make it bigger, and this scale factor will scale it down, all right. So these were some of the examples. Now let us take a polygon. Let us say we have got two pentagons, and the dimensions are 3 centimeter, 4 centimeter, 3 centimeter, 4 centimeter and 3.2 centimeter. Okay, let us take the angles. Let us say this angle is 100 degrees, this one is 130 degrees, this angle is 90 degrees, this angle is 120 degrees. Okay, now is in this triangle, let us say this is 4.5 centimeter, this is 6 centimeter, this is 4.5 centimeter, this is 6 centimeter, and this side, what I am doing is I am multiplying each of the sides with 1.5. So 3.2 when multiplied with 1.5 will give us 4.8, right. So let us take it as 4.8 centimeter. Now I have taken all the sides of both the figures, and let me take the angles also. Let us say this angle is 130, this is 100, this is 90, this is 120, and this is same like this. Why? Because some of the interior angles of both the pentagons are same. Some of the interior angles for both the pentagons is same. So, if 4 angles I have taken as same, then the fifth angle has to be same. Now, look at this. If I multiply this side by 1.5, I will obtain this side. Similarly, if I multiply this by 1.5, I will obtain this. This is how I made these figures to start with. Okay. So, what I want to say here is that if I stretch this figure equally from all the sides 1.5 times, okay, then I will obtain this figure. So, these two figures are similar to each other. What makes them similar is that all the angles are equal, right, and all the sides are they equal? No, they are proportional. So, all the angles are equal and all the sides are proportional. That means these figures or these pentagons are similar. So, this is the criteria in case of polygons, that if all the angles are equal and all the sides are proportional, then the two polygons will be similar in nature. Okay. Now, triangles are special kind of polygons, right. Now, we have spoken about angles and sides. In a triangle, you have got 3 interior angles, 3 sides, right. Let us say we have got 2 triangles. Now, using this logic, we can say if all the 3 angles are equal and all the 3 sides are proportional. We will also talk in this chapter about correspondence. When I say all the 3 sides are proportional, then I mean the corresponding sides are proportional. What I mean is, let us say if this angle is 45, this angle is, let us say, 60, what will be this angle? This is 105, so this angle will be 75, right. And in this triangle, if this is 60, this is 45, this is 75. What I mean by the correspondence or corresponding sides, I mean if side opposite to 60 degree, that is this side, is proportional to this side, that means the ratio of these two sides should be equal to ratio of these two sides. By these signs, I do not mean these sides are equal, right. I am just marking them to denote the proportionality, correspondence of proportionality. That means the side opposite to 75 degrees and side opposite to 75 degrees in this figure, the ratio of these sides should be equal to the ratio of the sides opposite to angle 60 degrees. Similarly, the ratio of sides opposite to 45 degree and opposite to this 45 degree here should be same. Then I will say all the 3 sides are proportional. Okay. Now, I used this logic of polygons to tell you about the similarity in triangles, but triangle is a special case of polygons. In the triangle, let us say we have considered 6 conditions, 3 angles and 3 sides. Out of these 6 conditions, only if 3 conditions are met, even then we can say that these triangles are similar. Why? Because if, let us say, 2 angles, and these conditions are very specific conditions, we will study in the lectures that are coming up. So, 3 conditions are specific conditions. For example, if let us say 2 sides and included angle, if these two sides are proportional and the included angle is equal. What I mean is, let us say these two sides, ratio of these two sides is equal to the ratio of these two sides, and this angle is equal to this angle, right? It is enough to tell us that these two triangles are similar. Okay. Out of these 6 conditions, if only let us say these 3 are met, that these 3 angles are equal for both these triangles, then these two triangles are similar. Or only this, that the 3 sides are proportional in both the triangles, even then these are similar. We will talk about rest of the criteria in the upcoming lectures. So this and can be written as or by now, right? So all the 3 angles are equal, then the triangles are similar. We do not have to talk about this because this will automatically happen if the first thing happens. And I have written or here. So if all the 3 sides are proportional, we can very well say that the triangles are similar. We don't have to worry about the angles because these will automatically be equal, right? We will study in the upcoming lectures about this. So this is about similarity of triangles.